Hello everyone. In this presentation, I'll be talking about the need for supporting multiple distributed gateway ports for a logical router in OVN and the behavior of such a configuration. A quick overview of distributed gateway ports. Distributed gateway ports are router patch ports that connect logical routers to logical switches attached to physical or underlay networks. Some of the logical router flows for distributed gateway ports need to be processed on a specific chassis in a centralized manner, like doing one-to-many SNAT and replying to ARP or neighbor discovery for distributed gateway port IPs. More information about distributed gateway ports can be found in OVN architecture and OVN NOT documentation. In this simple topology, a logical router is connected to two overlay logical switches and an external network with IP prefix 10.15.36.0/24 using a distributed gateway port. When traffic from the VMs attached to overlay logical switches needs to go into the external network, the source IP address of the packets will be translated to the router IP 10.15.36.25 by the centralized flows associated with the distributed gateway port. OVN allows creating only one distributed gateway port per logical router by default. We added support for creating multiple distributed gateway ports per logical router in OVN 21.09. This allows connecting a logical router to multiple external or underlay networks. Changes to support NAT and load balancer on logical routers with multiple DGPs is still under review. I would like to thank Ankur, Datri, and Han for their help in making these changes. Let's look at how we can use multiple distributed gateway ports. Consider the following scenario where a logical router has two overlay logical switches, 20.110/24 and 30.110/24, that VMs are connected to. The logical router is connected to external or underlay network ext-s1, whose IP prefix is 206.80.140.0/24 with one DGP, and it is connected to another external network ext-s2 with IP prefix 10.15.38.0/24 using another DGP. The external network ext-s1 provides access to internet for the VMs. The logical router has a default route with external gateway 206.80.140.1 as the next hop. When VMs need to send traffic to the internet, the source IP gets translated to the router IP 206.80.140.25. External network ext-s2 allows the VMs to talk with an internal network. This internal network could have some shared services hosted on another data center, or it could have hardware appliances in the same data center. It is represented here as a.b.0.0/16. The logical router has route with destination prefix a.b.0.0/16 and next hop as 10.15.38.1, which is ext-s2's gateway router. Traffic from the VMs to the external network ext-s2 is not translated, so the shared services will see traffic with the logical IPs of the VMs. The external gateway 10.15.38.1 has routes to send the return traffic to the logical router IP 10.15.38.25. Consider a similar topology as the previous slide, where a logical router is connected to two different external networks, ext-s1 with IP prefix 10.15.36.0/24 and ext-s2 with IP prefix 10.15.37.0/24 using two DGPs. Unlike the previous setting, VM packets need to be translated to an IP in the external or underlay networks before entering either networks. The logical router has four NAT rules as shown. If a VM with IP 20.11.42 needs to talk to 8.8.8, logical router will route the traffic to gateway of ext-s1 10.15.36.1 based on the routes, and it needs to apply NAT rule 1 and not NAT rule 2 to translate the source IP to 10.15.36.25. Similarly, if the same VM with IP 20.11.42 needs to talk to 192.168.10.10, traffic will go through ext-s2 and logical router needs to apply NAT rule 2 and not NAT rule 1 to translate the source IP to 10.15.37.25. In general, when multiple distributed gateway ports are configured for a logical router, a NAT rule is applied on a matching packet entering or exiting a specific DGP only if the external IP of the rule belongs to the same subnet as the DGP. In this case, NAT rules 1, 3 are applied to matching packets entering or leaving the ext-s1 DGP as the external IPs of these rules are in the same subnet as ext-s1 10.15.36.0/24. Similarly, only NAT rule 2 is applied at ext-s2 DGP since 10.15.37.25 is the router IP. Rule 4, whose external IP is 10.15.38.11, will not be applied at either DGPs. As seen in the previous slide, for NAT rules, specifically SNAT, we need to bind a subset of the rules at each DGP for correctness. But for load balancer rules, where we change the destination IP address from virtual IP to a private endpoint IP, we have a choice to either bind rules whose virtual IP is in same subnet as DGP to a DGP, or bind all load balancer rules to each distributed gateway port. Thank you.
I want to welcome our speaker, Abhiram Sangana, to join me in audio and video to discuss the presentation. We don't currently have questions. I hope that somebody will submit one. Before we get there, Abhiram, would you like to just say anything more about your talk or your work?
Thanks, Ben. I don't have anything specific to add besides this. So we still have a couple of patches that need to be merged, so we're just waiting for that.
Okay. I know that a review tends to be kind of a recurring issue for OVS and OVN and a lot of open source projects. How have you found the review experience so far?
Oh, I think the community has been really helpful with reviewing. I mean, like once somebody has like taken up the patch for reviewing, when you send out the next set of patches, they always try to stick to it and help it get converged. So that has really been helpful.
I'm glad it's working out that way. So I'll give it a few more seconds to see if anybody wants to submit a question. Assuming that they don't, is there maybe you want to say something about future directions or anything else?
Right. So one thing that still needs to be fixed is that we still need to figure out, as mentioned in the last slide, like what we need to do with these load balancer rules. We still have like two options left on how we want to figure out whether load balancer rules need to be bound to a specific DGP, or do we want to add all the load balancer rules to each of the DGPs. So that is one work that still needs to be done. Like that patch, we haven't even yet started work on it. And another thing is that we've noticed that there has been a problem with your CT zone on the AHVs. We've noticed that sometimes your previous connection tracking entries don't get flushed. So it's possible that if you had a NAT rule which was like an SNAT rule where your logical IP was getting translated to say 90.11.10, and let's say I delete that NAT rule and add another NAT rule that converts my SNAT IP, my logical IP to say 90.11.25, but a connection is ongoing. We observe that because of the way OVS interacts with NetFilter, the existing connection was still getting translated to 91.110, even though that rule got removed. So that is one more thing that needs to be fixed that we're working on.
All right, I'm glad that you're looking into corner cases like that. Thanks again for your talk and your work.